All right, let's get started. Today, we're tackling the absolute foundation of all physics. I mean, we're literally talking about the language the universe is written in, units and measurement.
Hello, Neet Aspirants! So, have you ever stopped to think about this? How is it possible that we can describe something as simple as a falling apple, right here on Earth, and then use the exact same language to describe a distant star millions of light years away? Well, the answer, and it's a big one, is all about having a universal system of measurement.
Okay, so let's get right to the heart of it. Physics isn't just about ideas, it's a quantitative science. And what does that mean? It means everything, and I mean everything, is built on the idea of measurement. It's basically the science of comparing something you don't know to a known standard that everyone agrees on.
So, what is a measurement, really? Well, it's just comparing some physical quantity, anything really, with a basic internationally accepted reference standard. And we call that standard a unit. Now, this is super important, so listen up. A measurement always has two parts, a number and a unit. If you just say the distance is 5, that means nothing. Is it 5 meters, 5 kilometers, 5 inches? See? In physics, a number without its unit is completely useless.
Now, to make all this a bit easier, just think of units in two main types. First, you've got your fundamental or base units. I want you to think of these as the letters of the physics alphabet. There are only 7 of them. That's it. They're the core building blocks. Then you have derived units. And if the base units are the letters, well, the derived units are the words of physics. You can create a basically infinite number of these words just by combining those 7 fundamental letters in all sorts of ways.
So you ready to meet this alphabet? The whole system that's accepted globally, the grammar of physics, is called the SI system. And it's all built on those 7 fundamental units we just talked about.
And here they are. Seriously, these are the only 7 base units you need to memorize for your exams. For length, we've got the meter. For mass, it's the kilogram. For time, you guessed it, the second. Electric current is measured in amperes. Thermodynamic temperature, that's Kelvin. The amount of a substance is the mole. And finally, luminous intensity is the candela. And that's the whole shebang. Every single other unit in physics is just some combination of these 7.
Okay, so we've got our letters down. Now for the fun part. Let's start forming some words. This is where you'll really see the power of this system, because we can combine these simple base units to describe much more complex stuff.
Let's kick things off with something you definitely know, velocity. What's the formula? It's just displacement divided by time, right? And displacement is really just a measure of length. So all we do is take the base unit for length, the meter, and divide it by the base unit for time, the second. And what do you get? Meters per second. See? Simple as that.
All right, how about another one? Density. We know the formula is mass divided by volume. Okay, so what's the base unit for mass? The kilogram. And what about volume? Well, volume is just length times length times length, so its unit is going to be meters cubed. You just combine those, and bam! The derived unit for density is kilograms per cubic meter.
Okay, let's tackle a slightly trickier one, force. We're going to do this step by step. Step 1, what's the formula? You know this one, F equals m times a. Force equals mass times acceleration. Simple. Step 2, let's substitute in the units. The unit for mass is the kilogram, right? And the unit for acceleration is meters per second squared. Step 3, now we just combine them. We multiply kg by m/s squared, and we get kilogram meter per second squared. Now this is a perfect example of how we build up these complex words. This big clunky unit, kilogram meter per second squared, is so important it gets its own special name, the Newton. And we just write that as a capital N. So, we have our 7 letters, and we're building words. But what about punctuation? Well, there are 2 special units that kind of act like that. They're called supplementary units, and we use them specifically for describing angles.
There are basically 2 types you need to know. First, for 2D shapes, we have the plane angle. It's just the ratio of the arc length to the radius of a circle, and its unit is the radian. Then, for 3D space, we have the solid angle. It's the ratio of an intercepted area on a sphere to the radius squared, and its unit is the steradian. Now here's the cool part. Since both of these are ratios of similar things, like for the radian, it's lengths divided by length, or meters divided by meters, the units actually cancel each other out, and that's why we call them dimensionless. Pretty neat, huh?
Okay, so let's boil this all down. What are the absolute key takeaways for your NEET prep? Number 1, physics is measurement. Always remember, it's a number plus a unit. Number 2, there are only 7 fundamental units to memorize. That's it. Number 3, Every other unit is a derived unit, built from those 7. So, number 4, make sure you know your formulas for things like force, velocity, and density so you can figure out their units on the fly. And finally, number 5, don't forget those 2 special supplementary units for angles, the radian and the stereo.
If you found this video helpful, please like, comment, and subscribe for more physics content.